Electric vehicles have two separate systems. Again, 12 volt like conventional vehicle and high voltage for my electric motor. So the 12 volt system is going to power up my EV computers to control my high voltage system. It's also going to do all my conventional systems, and it's going to use a chassis ground. My high voltage is going to use an isolated ground where I've got two cables, a positive and negative coming out of my battery that's going to my inverter, and then we're going to take and turn that into AC three-phase to drive my motors. Now, we'll talk about contactors and relays. You're going to have two contactors inside my battery pack, and these are going to be inside the battery pack, so you're not going to be dealing with these. But they use this for redundancy, so we don't have any kind of problem at all. I'm going to disconnect positive and negative coming out of the battery pack. It's with high voltage relays. They're normally off, so a computer has to turn them on. So if there's any malfunction with the system, if I'm in a wreck and I have an airbag deploy, or my crash sensor sees a crash detected, it's going to open these contactors and it's going to prevent power from coming out of the battery pack. I'll show you where they're at. I got two batteries back here. I've got one discharge battery that I could open up, and I'll show you where everything's at and where the cabling is going once you get inside this battery. Then I'll show you the battery that actually runs the car and how it's going to look when you're working on it. I've got an interlock system. So the interlock system, what they do is they want to make sure everything's connected. So they run low voltage through my entire system that tells the computer that all my cables are plugged in, all my connectors are in, everything's functional. Once it sees that my interlocks are complete, it turns my high voltage system on. If it's interrupted at all, if I open up my interlock, it's going to turn off the high voltage. And that's one way we can actually disable the high voltage, by opening up my interlock. Two major types of batteries. Again, I talked about lithium ion and nickel metal hydride. They're both high voltage. They can be anywhere from 200 to 800 volts. We have an intermediate voltage battery that they use for a short time. I don't know if any of them are being used right now, but you see that they're in a blue. Blue is from 30 to 60 volts. Anything over 60 volts is going to be orange cabling. EV traction motors. Traction motor is nothing more than just the motor that drives the wheels. They might have more than one. They could have two motors and generators. They have one motor, one generator. Depends on the configuration you want to use. As we're operating this vehicle, we're taking DC, inverting it to AC, and taking AC, converting it back down to DC. And we do it at different times. When we accelerate, we take DC current from my battery pack, invert it into three-phase AC to drive my motors. When we decelerate, we turn the AC motor into a generator, and it's going to take the AC, convert it back into DC, and store it as energy in the battery pack. So we gain a lot of efficiency that way. That's called regenerative braking. We also take and we convert DC to DC. So we're going to take my high voltage battery, we'll run it through my converter, and it converts it down to low voltage 12 volt. That's what I'm going to use to charge my battery, my 12 volt battery. That's essentially my alternator. Okay, and that's one area to where it was a little gray for a lot of the procedures, my policies and procedures they developed in the beginning. I want to make sure you're aware of this, because this can get you in a little bit of trouble if you're not aware of it. We have a charging system that's going to charge my 12 volts that could create an issue if I don't disable it correctly. And I'll go through the exact procedure and what you want to watch out for when we get on the car. What I'm going to do a demonstration for you right now on the importance of doing disabling procedure in a proper order. So I'm going to show you on this car how we're going to disable it. But I want to make sure you're aware of this, that this is our cutaway trainer. So this battery that's up here is a disabled battery, it's discharged. We only use it for demonstration only. The real battery is down here. So what I want to do is I'm going to go through a procedure and show you what could happen while you're on scene. This car is in ready mode right now. The ready light is on. The car is not running. So if I don't turn the key off first, before I disconnect the 12 volt battery, I can run into a problem. So I'm going to go through right now. I'll show you how to get to the battery, and then we'll disable it. So first thing you need to do is you need to remove this package tray. There's a compartment that needs to come out. Then I got a battery cover that needs to come out. So this battery's over in the right-hand corner. So what I'm going to do right now is I'm going to disconnect the 12 volt battery, just like we were cutting the 12 volt cable to disable this car. But I'm not shutting the key off yet. But I'm going to disconnect this. The 12 volt cable is disconnected right now. So this car has no 12 volt battery in it. So watch what happens. This car should be dead. This car starts and runs with no 12 volt battery in it. That's because it's got a charging function built into my high voltage battery to where it charges my 12 volt battery. So it'll allow the car to run. So you have to remember to do this in the right sequence. If we're going to disable the 12 volt system, you turn the key off first and then disconnect 12 volt battery. If you don't, this thing's still in ready mode to where it can start and run and it'll move, potentially hurting somebody, a firefighter or a victim.